All right, let's do this. All right, good morning, chemistry students. It's 9 a.m. It's Monday, April 13th. Here is your do now. I'd like you to pause the video and try to answer these two questions. So go ahead, pause that video now. All right, so we're gonna go over this quickly. We're gonna see a second part of a do now question, and then we're gonna go over a bunch of announcements, your meme of the day, and we're gonna start a new unit. So it's kind of a busy day today. So here we go. These first two questions are a bit of a sort of recall type questions, meaning there's not much work to do. You just got to solve them. So let me get my doodle pen here. So compared to a 26-gram sample of NaCl solid, that's sodium chloride, at STP, a 52-gram sample of NaCl solid at STP has what? Well, a different density? No, they are identical substances. They would have the exact same density. Different gram formula mass. If you went and did the gram formula mass of each of these, it's the same formula. Therefore, they'll have the same gram formula mass. Okay, the right answer is going to be number 3. Since they are identical in their chemical formula, they will have the same chemical properties. It's the same compound, they just have different masses. The same volume, that's not true. On one hand, while they have the same density is your mass per unit volume. It's that ratio of mass to volume. Since this has less mass than this sample, it's going to take up less space as well. So just because this has the same density as this sample of NaCl, because it has less mass, it will also have less volume. So they will not have the same volume. And that should make sense. If you have a little pile of sodium chloride that takes up 26 grams, and then you had one that was twice as heavy, you would expect it to take up more space. It would occupy a bigger volume. So number 4 should be incorrect as well. All right, number 20, a definition question. A gas changes directly to a solid during what? Well, this is probably one of the tricky ones. All the phase changes, there are 6 of them that you need to know. Melting, freezing, boiling, condensation, and then the tricky 2 are sublimation and deposition. So which one does a gas turn directly to a solid? So you have a gas. All right, you have those phase change diagrams. You have a gas, you have a liquid, and you have a solid. So you should know that gas to liquid is condensation, liquid to solid is freezing. But what's that weird one when you go from a gas directly to a solid? By definition, you should know that is deposition. Okay. Decomposition is a type of chemical reaction. Saponification is another type of chemical reaction that we'll talk about later in the year. And fusion, I guess, is referring to fusion is like freezing. But that's not even one of the phase changes that we know by that sort of name. So those were your wrong answers, and number 2, deposition, was your right answer. All right, I'm going to show you guys the second part of this do now, then you're going to pause the video and do that, and then we are going to move on. All right, so we are going to look at this question here. It's not as tricky as it looks. Pause the video, read it carefully. Think about your answer. What would your answer be? Like, develop a sentence in your head that you would give as your answer, and we'll go over it together. So pause the video now and answer it. Go. All right, so this question is, like I said, it looks pretty scary. There's a little paragraph here with like scientific notation, kilopascals, which is pressure. We haven't talked a lot about that. We got temperature and Kelvin, and we have like a lot of different moving parts to this. And this question looks really tricky, but we can totally do it if you stop and think. State what happens to the average kinetic energy, like focus on what we did last, text coding, of the gas molecules if the cabin temperature decreases. Well, you should know that the definition of temperature is average kinetic energy. So you could substitute this phrase here for that word. So now read this question and look how simple it sounds. State what happens to the average kinetic energy of the gas molecules if the cabin's average kinetic energy decreases. That's it. So your answer is that the average kinetic energy would decrease. Answering this question right simply depends on your ability to know that average kinetic energy is the definition of temperature. So if the average kinetic energy, if the temperature decreases, the average kinetic energy decreases. That's it. All right, so moving on, we're going to get into our objectives, our meme of the day, a quick quote that I want to talk to you guys about, and then some reminders, and we're going to go into a lesson. So here we go. By the end of today's lesson, the nuts and bolts, the heart and soul of today's lesson will be 2 different definitions of acids and bases. This is your first lesson on acids and bases, and it'll take about a week and a half to cover everything. But what you're going to walk away from this lesson with should be 2 different definitions of acids and 2 definitions of bases, and I need you to be able to apply those definitions to some basic questions. Okay, so you'll have exit slips that will see if you guys can do that. So you're going to identify Arrhenius acids and bases, and you're going to explain in writing why something is an Arrhenius acid or a base. That's the first definition, the Arrhenius definition. Secondly is you're going to identify Bronsted-Lowry acids and bases. And then you're going to explain in writing why a given substance is a Bronsted-Lowry acid or base. So you have Arrhenius acids and bases, and then you have Bronsted-Lowry acids and bases. And you need to be able to identify both and tell me the definitions of both. And that's what we're going to do today. All right, so here's your meme of the day. All right, so there is another unit here. This is our second full unit that will be done online. Judging by the fact that schools will be closed until the end of April, this will totally encapsulate, that amount of time will totally encapsulate this unit. So we are going to do acids and bases completely online. All right, really quick, I want to go over a little quote. I have a friend from home here that shared something with me over the weekend, and I want to share it with you guys and talk about it briefly, and then we're going to dive right in, okay? So hold on really quickly. That being said, I think we did a lengthy do now. We had a lengthy discussion about that. The lesson should be pretty quick. It's on acids and bases. So acids and bases, it will be about, usually if we were in class, it would be about a 2-week unit. It'll probably be about 2 weeks for us now. There are 2 definitions of acids and 2 definitions of bases. I'm going to give you those definitions. You're going to copy them down. We're going to look at your reference table, and then we're going to see if we can apply those definitions to a few simple questions in an exit slip. So skip that. The first guy, it's called the Arrhenius definition of acids and bases, and this guy was around in the late 1800s, and they say the following. So you're going to want to copy these down in your notebook so you have this. Arrhenius acid and Arrhenius base. I'll pause the video. You should copy these down. Arrhenius acid, substance that gives off H+ ions in solution. Arrhenius base, a substance that gives off OH- ions in solution. We'll also call this hydronium, and we'll call this, you should know this, hydroxide. So pause the video, copy that definition down now. All right, welcome back. So I'll show you guys in the reference table. I always like when we cover something new and we learn some new portion of the reference table, because I feel like the reference table represents this book of stuff you need to know for chemistry. And when we cover something new, it feels like we've covered another component, and we start to get closer and closer to like finishing that book and learning everything that there is to learn about chemistry within this New York State curriculum. So we have 2 more tables. On table K, you have the common acids table. And then really quickly, I'll show you table L, you have a common bases table. So really quickly, why don't you pause the video and think about this. What do you notice about all of these common acids? And sorry, it's sort of highlighted already, but take a minute, think about it. And how would you know that these are Arrhenius acids? See if you can connect what you see here on table K to the definition you copied. So go ahead, pause the video and think about it. All right, so going back to the definition, Arrhenius acids, they give off H+ ions in solution, meaning they let go of H's when they're dissolved in solution, which is usually water. So if you take an acid and put it in water, it's going to give off H+ ions. That's what it's saying. Well, look at all of the common acids on table K. They all have an H in front of them. So if acids give off H's, it would make sense that acids have H's. And that's what we find. Hydrochloric acid is HCl. Nitrous acid is HNO2. Nitric acid is HNO3. Some of these have more than one H, like phosphoric acid in your soda. It's one of the top ingredients in your soda if you like drinking soda pop. H3PO4. So acids have the H's, okay? And some of you guys remember now when we talked about acetic acid, HC2H3O2, the 2 different ways to write it, you'll see that this is another way of writing an acid. So we talked about that earlier in the year. We'll get to that in more detail in another unit. But again, acetic acid, these are essentially the same chemical formulas, just written 2 different ways. On the other hand, bases, according to your definition of bases, they usually feature OHs. So according to Arrhenius, if a substance gives off OH minus ions in solution, if a substance gives off hydroxide, it's going to be considered a base. Well, if they're going to give off OHs, they should have OHs in their chemical formula. So how do I know these are Arrhenius bases? Because they have OH in them. So if I took sodium hydroxide, dissolved it in water, you would have Na plus and OH minus. So sodium hydroxide gives off OH minus when it's dissolved in water. Hydrochloric acid, if you dissolve HCl in water, it gives off H plus and Cl minus. So acids have H pluses, bases have OH minuses. Okay, that's the key here for Arrhenius. So skip that. It's pretty self-explanatory. We're going to move more quickly here. Check for understanding. Where are my Arrhenius acids and where are my Arrhenius bases? Why don't you in a minute sort of like pinpoint the acids. I will circle them in red, and then pinpoint the bases, and I will circle them in blue. Pause the video. Go for it. All right. So I guess, I went to go skip through this one video or this one slide. I'll leave it up there in case any of you guys want to pause it if you'd like. But for me, I always just like the students just to think through it logically. All of the acids on the common acids table had the H at the head of the formula at the beginning. That's what you should be looking for in this list. So where are my acids? HBr, it's got the H at the front. If you go back to this slide here, it is bonded to a halide, so that is going to be an acid. NaH, the H is not on the front. That is not going to be an acid. Okay, H2SO4, that has the H on the front, and more importantly, it actually is one of the acids on the common acids table. Where are you? H2SO4. It's actually on the common acids table. HBr is not here because it's not a common acid, but it is there as well. Okay, so you have HBr, H2SO4, and that's it. Those are the two acids on the table. Where are my bases? Where are my Arrhenius bases? Well, we're looking for OH. So I have LiOH, it's lithium hydroxide, it has OH on the back end of the chemical formula, as well as calcium hydroxide, CaOH2. So this is a base, this is a base, these are my two acids, and for those of you guys who just caught my mistake, we actually have this guy as a base, and I forgot an acid over there. It'll be HF is also an acid. That's hydrofluoric acid. That's the acid that's featured in Breaking Bad when the guy dissolves the dude in the bathtub. That's hydrofluoric acid. So the three substances in red are my Arrhenius acids. How do I know? Because they have H's on the front. Okay. And then the Arrhenius bases will be LiOH, CaOH2, and NH4OH because they have the OH at the end. Okay? All right. So moving on. Part 2, round 2. There's another definition. Now, it's called the Bronsted-Lowry definition. You no longer need to know their names. When I was a high school chemistry student, we had to know they were called the Bronsted-Lowry acids and bases, named after two more scientists who were after Arrhenius. However, you no longer need to know their names. You just need to know that there's a second definition of acids and bases. And it's even easier than the Arrhenius definition to write down, but it's a little more difficult to understand. So an acid is a proton donor, and a base is a proton acceptor. Pause the video, copy it down, and we'll talk about it. Go. All right, so let's go back, and we'll actually deconstruct why this is not as scary as it sounds. Acids are going to give off. They're going to donate protons. And bases are going to accept protons. And that sounds kind of crazy, like, whoa, suddenly we're dealing with the nucleus here of atoms, or what's going on? You need to break down one key idea first. And to do that, we're going to do a little bit of a class rewind. Why don't you pause the video and try to do this right now in your notes as a class rewind, as a review of something we did a long time ago. So pause the video, try to do this, go. All right, so here it says to draw a Bohr model of a hydrogen 1 atom. Meaning I want you to actually draw the protons, neutrons, and electrons for the simplest atom that we've covered in class. This is going way back to when we were doing Bohr models. You guys do Bohr models of, you've done Bohr models of bigger, more complex atoms. So all I'm asking you guys to do is to go back and do a simple hydrogen 1 atom. Then I want you to copy your drawing and make it a hydrogen 1 plus 1 ion. So I'm asking you to do the hydrogen 1 atom and the hydrogen plus 1 ion, kind of like you did on the M&M lab a long time ago. Here's what you should have drawn. Your hydrogen 1 atom is 1 proton, no neutrons, and 1 electron. That's it. That's your hydrogen 1 atom. meaning which isotope is it? It's the isotope that has no neutrons because its mass of 1 comes only from the neutron. So this is a hydrogen 1 atom, a 1 proton, 1 electron with no neutron. How does a hydrogen 1 atom turn into a hydrogen plus 1 ion? It's got to lose that electron. And when it loses that electron, it has a plus 1 charge. So this would be H1 plus 1. Notice, what is a hydrogen ion? It's essentially just a proton. So if something is going to be gaining or losing H plus ions, it's going to be gaining and losing a proton. That's the way to think about it. So in this case, because hydrogen is so simple, it has so few subatomic particles that make it up, when it is an ion, it's nothing more than a proton floating around that's going to sort of either be donated by an acid or accepted by a base. So when you're talking about proton donors and proton acceptors, just think about how it's just hydrogen plus 1 is my proton. Is something giving away the H or is it receiving the H? Because that's the proton. All right, so here we go. Proton donor means giving up an H plus, and proton acceptor means accepting or taking the H plus. So why don't we take a minute and see if you can figure this out? The problem with these questions is now they're not so easy. You have to look at the entire equation. So when you talk about where is my proton donor and my proton acceptor, you have to look at the whole equation. So why don't you pause the video and tell me which of the products is gaining an H plus and which of the products has lost an H plus. You sort of have to take what's on the reactant side, like this, and what's on the product side, and you got to figure out how it's all coming together. Why don't you take a minute, pause the video, and determine which of the reactants is my proton donor and which one is my proton acceptor. Okay, go ahead, go for it. All right, so here we go. I'll do all my acid work in red. I'll do all my base work in blue. And you'll see as we start getting into pH why we do that. But for now, we're going to say, did H2O gain or give up an H? So let's focus on H2O. When H2O turned into OH minus, in order to do that, did it gain or lose an H? Well, it went from H2O to HO or OH. It lost an H. So it is going to have donated an H. It donated an H. It lost an H. So it donates an H. And then it turns into OH minus. So it donated an H plus. Okay? Now, on the other hand, look at the other guy. NH3. Did it give up or did it gain an H? Well, NH3 turns into NH4. So it had 3 H's at the start. Now it has 4 H's at the end. It had to accept an H. So what you always do is you look at how the reactants turned to products. And if the reactant it accepts an H. I'm just going to write H. I'll write H plus. Okay? So you look at the reactants and ask, as it goes from reactant to product, did it gain and accept an H or did it lose and donate an H? In this case, I always thought it was easier to start with the base. You have NH3 turning to NH4. Along the way, NH3 had to accept an H. Okay? On the other hand, H2O had 2 H's and 1 O. Now it only has 1 H and an O. It had to donate or lose an H. So H2O loses an H, NH3 gains an H. Therefore, H2O is an acid and NH3 is a base. Now you're thinking, wait a minute, water's an acid? Everything can be an acid or a base. It doesn't need to be a strong acid or a strong base, but in this particular case, water is acting as an acid. NH3 is acting as a base. And as a little side note, go back to your reference table if you'd like. Let's do this. Let's look at NH3. You'll notice that NH3 appears on your common bases table. Therefore, it makes total sense that NH3 would in fact try to accept an H. So going back here, this is the type of question that I'll need you to break down. Look at the reactants. As the reactant, did the reactant gain an H? If it did, you say it accepted an H, and therefore it's a base. Did the reactant lose an H? If it did, you say it donated an H, and therefore it's an acid. That's it. Those are your two definitions. So for review, hopefully you can identify an Arrhenius acid or an Arrhenius base. Arrhenius acids have H at the front. Arrhenius bases have OHs at the end. Why would a given substance be an Arrhenius acid or a base? Hopefully you can explain that as well, because Arrhenius acids give off H plus ions when they're dissolved in water. Arrhenius bases give off OH minus ions when they're dissolved in water. Bronsted-Lowry, or what we'll call the other definition of acids and bases. Acids are proton donors, bases are proton acceptors. Hopefully you can identify, when given a simple chemical equation, which substance in the reactant side is donating an H and which substance on the reactant side is accepting an H, and therefore you should be able to identify the Bronsted-Lowry acid and the Bronsted-Lowry base. All right, guys, I know that was probably longer. I haven't even looked at the timestamp yet. However, I will say this. We are doing a lesson every other day, only 2 days a week, on Monday and Wednesday. So these will be a little bit longer. I did want to take those 10 minutes or so to talk about that quote, because I think that these are very important times here. And I think it's important to check ourselves. I constantly reflect on how I am as a teacher. And so I want to take this very seriously. I want you guys to be the best versions of yourselves that you can possibly be. So I know this chemistry stuff isn't always the most exciting, but you know, at the end of the day, we're doing our best here to give you guys access to some resources, and to sort of put yourself in a position where you can learn and use your skills so that you guys can do whatever it is you want to do in life, okay? So don't just sink into your phones. Don't just cave in and sort of lock yourself in your house and sort of shut down. Dig in deep. Do your best to do this online learning. I posted some cool like extension activities on Google Classroom over the weekend. Go do them. Instead of watching Netflix, instead of sitting there on TikTok and social media, go learn something new. Go read a book, right? Do these activities that your teachers are posting. Get caught up on all your work. Do the best you possibly can do. If you guys need anything at all, email me. Join my office hours. If you ever want to talk, I'm here for you guys. But I really want to double down and work really hard. So I'm going to post these exit slips. I look forward to your responses. They're going to be due Wednesday, and you will have a new lesson from me on Wednesday. If you want to see me and talk to me about anything, my office hours are right now. I have them up, but no one's joined yet. And then tomorrow, my office hours are at 12:30. So remember, Monday, Wednesday, 9:30, and Tuesday, Thursday, 12:30. All right, guys, that's it. Have an amazing day. I hope you guys are staying safe, and I hope you guys are going to continue to work hard. All right? See you guys.